Okay, so I'm going to do an example congruence proof. This is question 2 from the exercise that you are going to do. Prove that ABP is congruent to DCP. Alright, so we've got two triangles. They look like they're joined at point P. We've got a pair of angles that are equal, and we've got a pair of sides that are equal. So looking tests involve three pieces of information. What we have right here, we've got two bits of information. We've got a pair of equal sides and we've got a pair of equal angles. We really need something else. But with our proof, we start with what we know, and we list what we know, and then we see how what's needed, and then what we try and do is we look for some geometry that some geometry that we know, some properties of shapes that we know, properties of angles. Often there might be some parallel lines that we can use, and we know that there are special angles with parallel lines. So we can use all of the geometry that we know to validate the statements that we make. So, all right, let's start by listing the things that we know. So we're doing part A, the proof. All right, so what do we know? What are we told? Well, angle BAP is equal to angle CDP, and so we state that angle BAP equals angle CDP. We always have to give a reason for our statements. Our reason in this case is that it's given. We're told it. Okay. We're also told that side AP is equal to side DP. And that is also given. Alright, so we need some more information from somewhere. We're not told anything about the lengths of CD or AB. We don't know that they're equal. Even though they look equal, we can't say that they're equal. We don't know. Same with BP and CP. They look equal, but we can't really state as a fact that they are. What do we know for sure? Well, you'll see that these two lines, the longer lines, so BD and AC, they cross over. And we know that when lines cross over, there are angles that are made, and those angles are equal. So we know that that angle in there, angle BPA, is equal to this angle in here, CPD. They're called vertically opposite angles, and you get them when two lines intersect. And vertically opposite angles are always equal, and so we can use that fact in our proof, and that'll give us another pair of equal angles, and that'll be enough for us to prove that those two triangles are congruent. And so we'll say angle BPA is equal to angle CDP. No, CPD. All right, and our reason, vertically opposite angles. Okay, so we can abbreviate like that. And so we've got now three bits of information. We've got two pairs of angles that are equal, and we've got a pair of sides that are equal. And so we can finish off our proof by saying, therefore, triangle ABP is congruent to triangle DCP. And our reason, based on the information that we've gathered, is AAS. Okay, so two pairs of angles that are equal and a pair of sides that are equal, and that's our proof done. Now, part B asks us to prove that BP equals PC. This is really straightforward, right? So this is part A. Part B just follows on from our proof. We've just proven in part A that these two triangles are congruent. Now, if they're congruent, then everything about one of them is exactly the same as the other. And so we can say for sure that, we already know that AP equals PD, we can say for sure that AB equals CD, and we can also say for sure that BP equals PC. So let's do that. So we can just say that BP, we can state that in one line. BP equals PC. We've just got to give a reason. And the reason we're going to give here is that they are corresponding sides of congruent triangles. And that's all we need to state. Similarly for part C, AB equals DC, exactly the same reason. They are corresponding sides of congruent triangles. And that's sufficient. All right, so I'm not even going to bother writing it. It's too simple. Right, so part C is exactly the same as part B. And there we go. There's our congruency proof example.